Hello everyone, in this lecture we will study about system in package under the heading basic concept. Let's begin. So system in package, or we can say a system in a package, is a number of integrated circuits that are enclosed in a single module. The system in package performs all or most of the functions of an electronic system, and it is typically used inside a mobile phone, or we can say a digital music player, etc. So the dies which are contained in integrated circuits may be stacked vertically on a substrate, one over the other, and they are internally conducted by a fine wire which is bounded to the package. Or we can alternatively use a flip chip technology where solder bumps are used to join stacked chips together. Okay, so system in package is simply a more function in less space, or we can say it is an optimized cost having a reduced design cycle. We all know Moore's law, a very famous law, that is the complexity of or minimum component cost has increased at a rate of roughly a factor of 2 per year. This been the said by Moore's in April 1965 by Gordon Moore, who is an Intel co-founder. Complexity for this minimum component cost will increase at a rate of roughly a factor of 2 per year, which we can see nowadays. Okay, why this system in package is used nowadays? We can see this system in package moves linearly with the system complexity and cost, or we can say function, which is time to market. So they both the factors are linear in the case of system in package. As the complexity increases, the cost will also increase. But if we compare it with system on chip, then in this case, as the complexity increases, the cost increases at a very high rate. Okay, so we can say this system in package is more cost efficient and if we compare it with system on chip. Okay, and we can say that this is a side by side, or we can say a superimposed package with different chips, while this system on chip is a highly integrated chip product. Okay, where the system in package can more simply be defined as a combination of multiple active electronic components with having different functions with optional passive devices. Okay, so it is basically a combination of active electronic components having different functions, and it may use passive device or not. While these can also include other devices such as lamps, optical devices, or we can say the system in package can achieve a certain function of a single standard package. SIP package form. The SIP technology accepts many types of bare chip and modules for arrangement and its assembly. And these bare chips and modules can be structured in either a planar arrangement, that is a 2D arrangement, or we can use a stacked arrangement, then that is one above the other, that is known as 3D arrangement. And this 3D packaging method specifically allows for more modules to be used in a smaller space and makes the overall functional integration which is more appealing. Then internally, the components can be bonded as we have already talked before using a wire bonding, or we can use a flip chip technology, or we can use a combination of the two. That is, wire bonding as well as flip chip can be used at the same time in the circuit. Okay. So in addition to this 2D and 3D package structure, it is also possible to use a multifunctional substrate to integrate components where the different components are built in the multifunction substrate to achieve the purpose of functional integration. Okay, so we can also use a multifunctional substrate where the different components are built in that substrate having a functional integration. So here you can see that the package structures look like where they have this thing that this W by B and flip chip can be used at the same time here by you having a side by side packaging. This is a 3D packaging. This is having W by B, this plus function, this and this flip off. Then embedded packaging is like this, having embedded passives, LTCC and IPVD. where the advanced technology, which is known as scale moduling, having all these components like embedded chip, multi-chip, fan-out WLP, TSV, 3D fan-out WLP. Okay, this is all about the basic of SIP package form. The technical difficulties of SIP system in package are the most common packaging method for SIP is the ball grid array technology. But there are complexity with using this particular technology and any other packaging method. And if we see the technical difficulties from a circuit design perspective, then the 3D chip packaging will have multiple die stacks. So this create a complication in how to lay out the packaging. Okay, for example, a multi-chip integration into a single package must account for spaces between traces, complex trace patterns, potential interfaces between devices, clock signal frequency differences, and many considerations about the physical size of each separate devices. So they are all the technical difficulties which we have to face when we are integrating, when we are fabricating using this system in package. And when doing the design, consideration about such arrangement, once taken, will be simulated with complex software to ensure system performance. And this is key since the actual process of fabrication is complex and the design should be well understood before proceeding. Okay, so these are the technical difficulties of SIP. Now, SIP packaging technology prospects. Compared to system integration on printed circuit board, this SIP maximizes system performance as well as eliminates any repackaging. It will shorten development cycle. It also reduces the cost and increases the integration. Okay, if we compare this SIP technology with SoC, that is system on chip, then it has the characteristic of high flexibility, high integration, short design cycle, low development cost, and easy access. This SIP package integrates other components such as passive components and antennas into a single package for a more complete system function. So this is SIP packaging technology prospects which have different advantages over other technologies. Okay, then from the point of view of application product, SIP is more suitable again for low cost, small area, high frequency and high speed and short-lived electronic products. Okay, which is especially used in power amplifier, GPS that is global positioning system, Bluetooth, portable product market such as image sensing module and memory cards. So they have a wide application in all these products. And these characteristics are also make these products highly applicable to industrial application, Internet of Things, which is a very trending nowadays, mobile phones, you know how popular they are, smart watches, smart bracelet, and smart glasses. So this system in package offer you a total package that can be used anywhere in any industry, having a higher level of application and higher level of advantages over other technologies, and it is used popularly. This is all about system in package. In the next lecture, we will study about hardware and software co-design. Thank you.